Good morning, everybody. So we are gonna go ahead and talk about a couple of things today. One is binomial distribution, and then we are going to go ahead and do the review for the midterm. So midterm is gonna be on Wednesday, this Wednesday, March 3, 2021. I'm gonna open the midterm at 6 a.m. and leave it open until 11:59 p.m. You can work on it as much as you want, as often as you want during this 18-hour window. And you can work on it, take a break and come back and work on it. As you take the test, on the bottom right corner, you'll see your score being live updated. So you'll see exactly how you're doing. And also you can try the answers for each question as many times as you want. So I'm trying to make it as flexible, as easy as possible for you. And also I have gotten several emails from people involving family members contacting COVID-19, being impacted by coronavirus. And also some people lost jobs and this and that. So what I have done, I have opened all the old homework because they couldn't do the homework on time because of either health issues or job related issues or some other issues. So what I have done, I have extended all the deadlines until 5:59 a.m. Wednesday morning. Okay, so at 6 o'clock the test will open, but you'll be able to work on all the past homework up until Wednesday morning 5:59 a.m. which is March 3rd. Hopefully this helps, and if any one of you run into any problem, particularly that relates to COVID-19, be it somebody in your family member or yourself being impacted by COVID-19, or if you have other issues that relates to COVID-19, particularly some people are losing jobs and this and that, or some other issues. These are I take it, and the college takes it very seriously. We are trying to be as helpful, as accommodating as possible during this, one of the most difficult times of our lives. So please do let me know, do not hesitate. I'm here to help you, know that, okay? So having said that, midterm is on Wednesday, and I will be covering everything up until binomial distribution, which I will touch on today. After the binomial distribution, I'm gonna do a review, okay? Rest of the class. And just to help you guys out, what I'm going to do, I'm gonna have a special office hours. Oops. Office hour, okay? On Tuesday, tomorrow. Tomorrow, let's say 7 p.m. Is that okay? 7 p.m. Is it a reasonable time for you guys?
Yes.
Yeah, so you finish work at 5 o'clock or so, or 6 o'clock. That should give you a little bit of time to go home and rest and have dinner and then be ready. So 7 p.m. tomorrow, Tuesday, which is March 2nd. On Tuesday, March 2nd, I'm gonna have a special office hour for the midterm. That's on Wednesday, March 3rd, okay? The review is gonna be at 7 p.m. I'll just take your questions. I'll go over the homework problems that you have done so far and take your questions basically on anything and everything that relates to the midterm and the homework. Okay, having said that, let's get to the materials. Before I get to the materials, anyone has any questions that I could answer for you, please? Anyone has any questions? No questions? Okay. Today we are going to talk about binomial distribution. Okay, binomial distribution. Binomial, the name kind of sounds two, bi means two, right? So that's exactly where it comes from. To learn about binomial distribution, I always give this very simple and yet very powerful example for you to be able to understand how binomial distribution works, or what are the properties or characteristics or attributes of binomial distribution. So I would like you to go ahead and pay attention to this example. So this is my example. MCQ, multiple choice quiz. Okay, MCQ or multiple choice quiz. You guys have taken MCQ. If you take a multiple choice quiz, what features do you have? Can you guys explore it for me? Just think out loud. What is it that you have in multiple choice quiz?
Multiple answers to pick from.
Yes, good. Multiple answers to pick from. So I'm going to write it here. Multiple answers. Anything else? Typically, you have fixed number of questions, right? You don't have infinitely many questions, or you don't have variable number of questions, right? Normally, your test consists of either 5, 10, 15, 20, or 100 questions, whatever it may be. So that's another feature. Anything else you can think of? It has two outcomes, right? Either you get the question right or you don't get it right. Either right or wrong. That's where the name comes from, binomial, I guess. Then number 4, questions are independent of each other. They are independent of each other. Because if you get question 1 right, that's not going to influence whether you're getting question 2 right or wrong. Like having babies. First year you have a baby, it's a boy or a girl, it doesn't matter. Let's say it's a girl first year. The second year is the same probability, 50% chance. It's not influenced by the fact that the first year you had a girl, second year you'll either have a girl or a boy. There is no bias or influence from the first year. So they are independent of each other. Okay, so let me summarize the characteristics of MCQ. Number 1, fixed number of questions. Fixed number of questions, but instead of questions, we're going to use the term trials. Fixed number of trials. Number 2, 2 outcomes for each trial. So 2 outcomes for each trial. Number 3, trials are independent, okay? Independent trials. Then number 4, there is one more thing I didn't mention here, is this. For each question, don't you have a fixed, for each question, you have a fixed chance or fixed probability of getting it right. So let's say for each question, you have 4 choices. Okay? Let's say you have 10 questions, but for each question, you have 4 choices. Now, if you were to guess, what are your chances of getting the question right? There will be only one choice that is correct, right? Let's say this is the correct choice, B. Then what are your chances of getting the question right by completely guessing? What is it? 1 out of 4, right? So what we call probability of success. Probability of success is fixed. That means it doesn't change. There is a 25% chance or 1 out of 4 chance that you will get this one right. Okay, 1 out of 4 chance that you'll get this right. Then next question also has the same probability. The one after that has the same probability. All of the questions in the multiple choice quiz that you're taking, it has the same chance of being correct. Questions have the same chance of being correct. That's what it is. So now, if you have a real world scenario that fits all these 4 criteria, you can apply the binomial distribution to solve a problem such as this, or find the probability associated with that real world event. Find the probability associated with that real world problem. So now let's go ahead and do a problem using this, what we just learned. So how do you find the probability for each of these for a scenario such as this? By using this formula. Probability of x, x is the random variable. Probability of x, x is the random variable, is gonna be NCX, which is this, times p to the power x times 1 minus p to the power n minus x. And let me break it down for you what these things mean, okay? So what does this mean? This is what it means. N is the number of trials, okay? So that means how many questions are there in the quiz, that's N. X is how many you're trying to get right. X is the number of questions that you're gonna get right. N is the total number of questions in the quiz. P is the probability that each question you will get correct by completely guessing. You can think of it that way. Or we say P is the probability of success. So again, N is the total number of trials. Always compare it with MCQ, okay? Always compare it with MCQ. Total number of trials is like total number of questions, okay? Then 2 outcomes means either you get the question right or you get it wrong. Independent trials, meaning one does not influence the outcome of any other questions. One does not influence the outcome of any other questions. And probability or chances of getting the question right by guessing is always the same for each question, okay? So remember these 4 attributes, then you're okay. Again, P of x is equal to NCX, P to the power x, 1 minus P to the power n minus x. X is the number of questions you get right. N is the total number of trials or total number of questions in the quiz. P is the probability that you get a question correct, or P is the probability of success. That means the probability of getting one question right by guessing, and that's it. If you have all of these values, you can find the probability. So there are real world problems. Right now is a perfect time to talk about it. Excuse me. Binomial distribution is a great example, a great probability distribution that could be used in solving real world problems. Right now, because of COVID-19, okay, many pharmaceutical companies are trying to come up with a vaccine. So let's say if pharmaceutical company ABC comes up with a vaccine, they need to test it, okay? So they give it to the general population who has contracted COVID or has not contracted COVID, and then they try to find out the effectiveness. What is the probability of success in the real world, and they could use binomial distribution to model it. Think of a vaccine for COVID-19, okay? It has 4 characteristics. Number 1, you give it to fixed number of people. Let's say you give it to n is equal to 1,000 people. You come up with a vaccine, you give it to fixed number of people. Now there are 2 outcomes, okay? There are 2 outcomes, whether the vaccine is effective or not effective, right? Number 3, trials are independent. That means patient 1 or client 1 receives the vaccine is not going to influence what happens to client 2 or client some other number, okay? So they are independent of each other. And number 4, you can think of the probability that this vaccine is going to be effective for people is pretty much approximately the same for everybody. So probability is constant. So do you see how these 4 criteria are exactly the same 4 criteria here? This is a completely real world problem. And then you can apply this binomial distribution to find out the probability that this vaccine, new vaccine that they develop for COVID-19 will be effective. And that's very important for you to understand. That's very important for you to realize that these are not some abstract concepts that I am conveying to you, but rather these are real world problems. These are models that could be used in the real world to solve problems that are meaningful to you. Having said that, let's go ahead and do a problem, okay? Before I go ahead and do the problem, let me define some of the terms that I'm going to be using, some of the variables kind of. P is the probability of success. Sometimes I will use Q. Some people use Q. Q is just the complement of P, okay? 1 minus P is Q. So this is what here is. And the mean or the average for binomial distribution, the population mean mu for binomial distribution. If you have a population that follows the binomial distribution, the average for the population is going to be n times P. N is the sample size, P is the probability of success, okay? Well, so, and then sigma is going to be square root of n P times 1 minus P. That's the standard deviation, population standard deviation and population mean. Okay, so let's move on. Here is a problem that would help you. I'm going to go through this problem step by step so that you guys feel very comfortable with it and you understand the concept. A student takes a multiple choice test consisting of 10 questions. So 10 questions means n is equal to 10. As you read the problem, extract the information. 4 choices for each question. So 4 choices. So that means you have to think there are 4 choices for each question, and out of those 4 choices, there is only one correct choice. So your P or probability of success is 1 out of 4 or 0.25. Okay. So a student takes a multiple choice test consisting of 10 questions and 4 choices for each question. Show that the above situation satisfies all the criteria for binomial probability distribution. There is something I added, countable, which is pretty straightforward. You really don't need it. You can count it 0, 1, 2, 3, 4, 5, 6. So if you're taking a multiple choice quiz, this is an MCQ, right? A multiple choice quiz. And in this MCQ, you can count the number of questions 0, 1, 2, 3, 4. And this is something, the first one, you really don't need it. I just put it there. So there are two outcomes. Are there two outcomes? Either the student gets the question correct or does not get it correct. So there are two outcomes. One, fixed number of questions / trials, which is true. There are fixed number of questions or trials. There are 10 of them. N is equal to 10. And the probability of success or getting the question correct is the same for each question. It's 1 out of 4 or 0.25. Questions / trials are independent of each other. That is, answering one question does not influence the outcome of the other questions. So the way you answer the first question is not going to have any bearing or any influence on any other question, or number 2 or number 5 or number 7. So if you get, let's say, number 10 correct, doesn't mean that you're going to get number 9 or number 2 correct. They are completely independent of each other. They do not influence each other. Okay? So all the 4 criteria, so remember, these 4 criteria for binomial distribution are satisfied for this scenario. Now we can use the binomial distribution formula, which is, we know, P of x is equal to NCX. Remember combination? P to the power x times 1 minus P to the power n minus x. This is the formula we are going to use. Now, let's start off with the actual answering of the questions, or actual finding the probabilities. Find the probability that a student gets exactly 5 questions right by pure guessing. So in essence, what you are trying to find out, what is the probability that x is going to be equal to 5, which is going to be, in our case, this formula, right? 10 C5, then P is 0.25 to the power 5 times 1 minus 0.25 to the power 10 minus 5, n minus x. So if I simplify it, I'm going to get probability of x is equal to 5, which is going to be 10C5. So 10C5 is, by the way, 10 factorial divided by 10 minus 5 factorial times 5 factorial times 0.25 to the power 5 times 1 minus 0.25 is 0.75 to the power 10 minus 5 is 5. That's what it is. Now, how you simplify this, let me just do it here. 10 factorial, I could do is 10 times 9 times 8 times 7 times 6 times 5 factorial. All of it divided by 5 factorial times 5 factorial. So other 5 factorial, I'm going to just write it out. 5 times 4 times 3 times 2 times 1. Now this and this cancel out. 5 times 2 is 10, and 10 are going to cancel out. 4 goes into 8 2 times. So it becomes 9 times 2 times 7 times 6. 9 times 2 times 7 times 6. If you do the math, what does it come out to? 9 times 2 all times 9 times 7. Okay, 756. Let me just double check it. 9 times 2 times 7 times 6. Yeah, 756. So this is gonna be
3 go
yeah.
into 9?
Huh? What is it?
Can't the 3 go into the 9 on top 3 times?
Oh yeah, I forgot. Thank you. 3. I missed one. So divided by 3. Thank you for catching. It's 252. Sorry. So divided by 3 is 252. Thank you for catching that. 252 times 0.25 to the power 5 times 0.75 to the power 5. If you simplify all of it, it comes out to be probability of x is equal to 5 is approximately 0.01913 or 1.913% chance. So if you completely guess the entire quiz, the chances that you will get exactly 5 questions correct is about 1.9% or roughly about 2%. Is this okay? Any question on this one, anybody? No questions? Okay. All right. Next, do another problem. Find the probability that a student gets less than 2 questions right by pure guessing. So less than 2, probability of x less than 2. So pay attention here. Less than 2 means what? X could be 1. Can x be anything else, by the way? X is the number of questions you get right. So x could be 1. Is there anything else it could be? The value of x?
It could also be 0.
Exactly. Thank you. Who is talking?
Jerry.
Jerry. Thank you, Jerry. Probability of x equal to 0. So that means finding the probability that a student gets less than 2 questions correct is the same as finding the probability of x equal to 1, finding the probability of x equal to 0, and adding the results. Now, while I am on the topic, I'd kind of like to ask you, what are the possible values for x? X is a random variable, isn't it? It is a random variable. It takes its value by chance. So getting the number of questions right. X is the number of questions that you get correct in a multiple choice test or multiple choice quiz. And that is going to be what? What are the possible values for x in this context? It could be 0, that means you get 0 questions right. It could be 1, you get 1 question right. It could be 2, 3, all the way up to what? 10. Can x be 11?
No.
No, because there are only 10 questions in this quiz. Can x be -5? No, because it doesn't make sense. X cannot be -5 or x cannot be 11. So let me just ask you this question. What is the probability that x is equal to 11? Let's say I write probability of x equal to 11. What is that probability? Zero. That cannot happen because that means you will never get 11 questions correct when the total number of questions is 10. So the probability that you will get x equal to 11, that's technically 0. So the x or probability of x equal to some other value, -5, that's also 0. This, in theory, this cannot happen. So anyway, so also x cannot be, so what about x is equal to 1.75? Is it possible? Can you have x
Yes.
equal to? Who is saying yes? Jerry? Not Jerry, I think.
Would it be yes? Because then you'd be like factoring out like how you did the problem with only guessing 5 right. You came out to like a 1 point something
No,
number.
I think, Alicia, you're thinking a bit harder than you should. Give yourself a little break. It's a simple, just think of it in a simple term. If you take a quiz, multiple choice quiz with 10 questions, can you get 1.75 questions right? Is it ever possible?
No.
No.
It's either 1, 2, 3.
Yeah,
There's
exactly.
no half a number. They're not going to give you a half a number.
Exactly. So that's why we call it discrete probability distribution. That's why we call it discrete probability distribution. Remember, then we will be talking about continuous probability distribution, which will be normal distribution and whatnot, okay? So this is called discrete probability distribution. All right, so let's go ahead and do the problem here. So let's clean it up. So find the probability of x less than 2, meaning you need to find the probability of x equal to 1 plus probability of x equal to 0. Since you're still learning, I'm gonna do both of them. Let me just do this one. What is the probability of x equal to 0, which should be about 5%. So let's go ahead and work on this. Probability of x equal to 0, meaning you get no questions correct, is gonna be 10C0 0.25 p to the power x. So let me write it down here so that you have it in front of you. Probability of x is equal to ncx p to the power x times 1 minus p to the power n minus x. Okay, so n is 10, x is 0, n is 10, x is 0, p is 0.25 to the power x, which is 10, right? Sorry, 0, not 10. 0 times 1 minus 0.25 to the power 10 minus 0. If you write it out, you're going to get 10C0 0.25 to the power 0 is what? Can anybody give me the answer to that? 0.25 to the power 0. What is it?
1.
1. Any number raised to the power 0 is 1, except if a is 0, 0 to the power 0 is undefined. Okay? If it is any number other than 0, then that number to the power 0 is always 1. Only time it is not defined if it is 0, 0 to the power 0 is undefined. So 1 minus 0.25 is 0.75 to the power 10. So this is going to be 10C0. 10C0 is 10 factorial divided by 10 minus 0 factorial times 0 factorial, which is 10 factorial divided by 10 minus 0 is 10 factorial. What is 0 factorial? Do you remember? That's one of the first things that I have defined when we talked about factorials. 0 factorial is, by definition, 1. So 10 factorial cancel out, that gives you 1. So this is nothing but 1. So in essence, the answer becomes 0.75 to the power 10, which is roughly about 0.75 to the power 10. That's 0.05631. Okay, so you have about 5.631% chance of getting 0 questions right. That means getting nothing right. So now you find this, then you do the exact same calculation for 1. And if you do that, you'll get this number. So if you add these two numbers, this is probability of x equal to 0. This is probability of x equal to 1. And if you add these two numbers, after you add them, you get 0.2440 or 24.4%. So your chances of getting less than 2 questions right is about 24.4%. Is it okay, guys? Everybody? Anybody confused about any of the steps in this problem? Okay, let's move on. Find the probability that a student gets more than 8 questions right by pure guessing. Okay, So 8 questions right by pure guessing. More than 8, meaning it's going to be x equal to 9 and x equal to 10. So you should be able to find it. So probability of x equal to 9 is going to be what? So find the probability that the student gets more than 8 questions right. So remember, probability of x greater than 8, which is probability of x equal to 9 plus the probability of x is equal to 10. All right, that's what it is. Now, probability of x equal to 9, again, the same process. So let's take the background of probability of x is equal to 9, which is the same as 10 C9.25 to the power 9 times 1 minus 0.25 to the power 10 minus 9. And again, we are using the formula P of x is equal to NCX times P to the power x times 1 minus P to the power n minus x. You just use this formula and plug it in. Now, everything is pretty straightforward. So if I continue doing it, 10 C9.25 to the power 9 times 1 minus 0.25 is 0.75 to the power 10 minus 9 is 1. 0.75 to the power 1 is just 0.75. Now 10 C9 or combination of 9 items from 10 items is going to be 10 distinct items is going to be 10 factorial divided by 10 minus 9 factorial times 9 factorial is 10 factorial divided by 10 minus 9 is 1 factorial, right? 10 minus 9 factorial, 1 factorial is just 1. 9 factorial, I can write it as 10 times 9 factorial divided by 1 factorial is just 1, so we don't need to write it. 9 factorial, 9 cancel out, that gives you 10. So this is going to be 10 times 0.25 to the power 9 times 0.75. So now if you simplify it, you should get an answer. What is it? 0.25 to the power 9 times 0.75 times 10, and it's a very small number, 0.00002, I think. Okay, that's what I have. So let's, yeah, 0.0000286, something like that. 86, very small chance. Now, what is the probability that you will get 10 questions right? So probability of x is equal to 10, exactly the same process. You just do the, I'm even going to write it out for you, 10 C10, which is just 1. By the way, 10 C10 is 1 because 10 C10 is equal to 10 factorial divided by 10 minus 10 factorial times 10 factorial, which is 10 factorial. 10 minus 10 is 0. 0 factorial times 10 factorial, which is 10 factorial, 10 factorial cancel out. 1 over 0 factorial. 0 factorial is 1, so 1. So times 0.25 to the power 10 times 1 minus 0.25 to the power 10 minus 10, which is going to be, this is just 1. This is going to be 0.25 to the power 10 times 1 minus 0.25 is 0.75. 10 minus 10 is 0, which is 0.25 to the power 10 times 0.75 to the power 0 is 1. So 0.25 to the power 10 is a really, really small number, 0.00123456 7, right? So 9. something really small number. I probably have it here, right there. Yeah. And if you add these two numbers, you get another small number right here, which is not really that big, okay? So that's how you'll be doing these problems. Any questions, anybody?
I don't understand the factorial thing. Like, I don't get it. I don't like, how are you solving for it?
So factorial, there is a lecture on factorial. So I'll just briefly give you this thing. Factorial is defined as this. So let's say, first of all, remember 0 factorial is defined as 1. 1 factorial is just 1. 2 factorial is 2 times 1 is equal to 2. 3 factorial is 3 times 2 times 1 is 6. 4 factorial is 4 times 3 times 2 times 1 is 24. So factorial is basically product of first n integers. So n factorial is 1, 2, 3, 4, 5, 6, all the way up to n. Now 5 factorial is gonna be 5 times 4 times 3 times 2 times 1, which is 120. 6 factorial is gonna be 6 times 5 times 4 times 3 times 2 times 1, which is 720. So 6 factorial is the product of first 6 integers, positive integers. 7 factorial is the product of first 7 positive integers. In general, n factorial is the product of n integers. So it's going to be n times n minus 1 all the way down to 3 times 2 times 1. So is it okay, Sierra? Now, do you understand what a factorial is?
Yes, thank you.
Now, to simplify the factorial, I gave an example. So you may want to watch the video and read the class notes or lecture notes that I sent out. How to simplify something like 16 factorial divided by 12 factorial times 4 factorial, which is 16 factorial. I could write as 16 times 15 times 14 times 13 times all the way down to 1, but I'm not going to do it. I'm going to stop here and write it as 12 factorial. Why? Because there is a 12 factorial at the bottom. So 12 factorial in the bottom, that's going to cancel out. Then 4 factorial, I could write it as 4 times 3 times 2 times 1. Now this cancel out. Then 4 goes into 16 4 times, 2 goes into 4 2 times, 3 goes into 15 5 times. Now you multiply the remaining numbers, 2 times 5 times 14 times 13. Okay, that's what it is. All right, so that's what it is. That's binomial distribution, guys, for you. Now, this is the last problem I'll do from the binomial distribution. And that should end the binomial distribution. Oh, this. Oh, where is my question? I missed it. Okay, there you go. So a new drug named curates that is 60% effective in extending the average life of an AIDS patient by 20 years or more. So they have an experimental drug for AIDS that's 60% effective in extending the life of a patient by 20 years or more. 5 randomly selected 8 patients from Africa are treated with this new drug. Answer the following questions based on above information. Okay. Answer the following questions based on above information. Does it satisfy the conditions of the binomial distribution? The answer is yes, it does. Okay. So you can count them 0, 1, 2, 3. So there's countable. There are two outcomes. Either it extends life by 20 years or it doesn't. So two outcomes. So that's important. There are two outcomes. And the fixed number of trials or patients in this case who are receiving the experimental drug, there's N is 5. The probability of success, which is extending the life by 20 years, is 60% or 0.6. So if you look at the conditions, it's kind of all being satisfied. Now, the last one is the trials are independent. If patient 1 receives the experimental drug, it is not going to influence how the outcome is going to be for another patient. Okay, one patient is not related to another patient in any way. They are independent of each other. They don't influence each other's outcomes. So that's what it is. So all 4 conditions for binomial distributions are satisfied. Okay, all 4 conditions. 2 outcomes, fixed number of trials. Okay, then probability of success is fixed, which is 60%, P is 0.6, and the trials are independent, meaning one patient's outcome or one patient does not influence another patient. Okay, now we can go ahead and answer the following question. In this one, I ask you to find all the probabilities, okay? Do it for all values of X. Now, what are the possible values that X can take here? Can anybody help me out with that? What are the possible values that X can take?
0.60.
What is it?
0.60.
I'm sorry, I couldn't understand you for some reason. Could you repeat that again, please?
Would it be 0.60?
No. X is the number of patients that get
8. Sorry, 8.
okay, so
There's
let me
8 people, right?
no, 5 people. So X is the number of patients who extend life by 20 years or more. X is the number of patients who extend life by 20 years or more. Okay, so what are the possible values for this random variable X in this context? Again, it's kind of like the quiz problem that you just did. No patients could extend lives. One patient could extend life out of 5, 2 or 3 or 4 or 5. That's all it is. Can 6 patients extend lives by 20 years or more? The answer is no, because you only have 5 patients who received the drug. So does it make sense to say that a 2.1 patient extended lives? The answer is no, because it doesn't make sense. Or -5 people extended life? The answer is no. Or 7 people extended life? The answer is no, right? So you have to kind of be sure about what are the possible values that this random variable X can take. Okay, what are the possible values that this random variable X can take? Now, let's go ahead and find the probabilities. So I'm gonna just find maybe, I don't know, probability of X equal to 3. So let's clear up the screen. We want to find out what is the probability that exactly 3 patients out of these 5 will extend lives. So P of x is equal to ncx p to the power x times 1 minus p to the power n minus x. Remember the formula. N is, so here n is equal to 5. In this particular case, x is equal to 3, and your p is equal to probability of success, which is 0.6. So you just plug in these values, you get 5, C3, p is 0.6 to the power x, x is 3 times 1 minus 0.6 to the power n minus x. N is 5 minus x is 3. Now you just need to simplify it. 5c3 0.6 to the power 3 times 1 minus 0.6 is 0.4 to the power 5 minus 3 is 2. Now let me go ahead and simplify 5c3, which is going to be 5 factorial divided by 5 minus 3 factorial times 3 factorial, which is going to be 5 factorial times 5 minus 3 is 2 factorial. 5 minus 3 factorial is 2 factorial, and then 3 factorial. Then 5 factorial is 5 times 4 times 3 factorial, right? Why do I go down to 3, not further? Because there is the biggest factorial in the bottom is 3 factorial. So this is 3 factorial in the bottom, then 2 factorial is 2 times 1. Now you can cancel it, right? 2 goes into 4 2 times, 5 times 2 is 10. So this is going to be equal to 10. So you can take this number and plug it in here. Probability of x is equal to 3 is going to be 5c3, which is 10 times 0.6 to the power 3 times 0.4 square. And if I simplify all of this using my calculator, 0.4 to the power 2 times 0.6 to the power 3 times 10. Okay, that's gonna give me 0.3456. So the probability that exactly 3 patients extend their lives by 20 years or more is, by the way, 34.56%. Okay. Any question on this? Anybody? Everybody okay with it? Do you guys feel that I should do more examples of this, or can you handle it from here?
Thank you for putting the like answer kind of in a different color and setting it up how you set it up so that it's like a better example on how to get to those numbers.
Okay, you're welcome. So yeah, all of these things I have done here, by the way. I kind of gave you the answers here, right? Where is it? Right here. So that way, oops, here. That way, when you do the work, you'll be able to see, okay, whether you're getting it right or not. Any question, anybody? All right. So, are you sure, everybody? You can find out these probabilities. So now you will have to find it for x equal to 0, x equal to 1, 2, 3, 4, 5, all of them. If you understood what I did so far, you should have no difficulties in finding all of this, okay? And I have done one of them here. Do you think I should do one or two more, or are you okay, everybody? I think you should be okay. I have done quite a few of them. Anybody, you want me to do one more?
I think we're okay.
Okay. All right. In that case, let me just go ahead and continue with the problem. So assuming that you have all these numbers, right, these ones, answering the rest of the questions becomes really easy. What is the probability that no more than 4 patients extend lives? No more than 4. No more than 4 means is 4 or less, which is to say you're trying to find the probability of x is less than 4, equal to 4. No more than 4 means x is less than or equal to 4. So x is less than equal to 4 means x is 4, x is 3, x is 2, x is 1, or x is 0. But you already found those values here, right? You already found those values there. You just plug it in here for each of them. Then yes, you get that 92.22% chance that less than or equal to 4 patients extend their lives. Less than or equal to. Remember, the question is kind of slightly differently worded. Probability that more than 4 patients extend lives. Find the probability that more than 4 patients extend lives. That is the part. More than 4 patients extend lives. No more, sorry, I meant to say no more than. No more than 4 patients. So this is where people sometimes get confused. No more than. It's not, if you try it in probability notation, you don't say x greater than 4 or x greater than equal to 4. They're saying at least 4. This is at least 4. That means 4 or more. On the other hand, no more than 4, or no more than 4, which is equivalently saying at most 4. At most 4, which is to say probability of x is less than or equal to 4. Look at the difference between the two. This is greater than or equal to, this is less than or equal to. So these wordings could be a bit confusing. So make sure that you are okay with it. Next, what is the question? Did I miss anything here? Oh yeah, no. Okay. Find the probability that more than 2 patients, or less than or equal to 5 patients. So that's kind of tricky. More than 2 patients. So you want x greater than 2. That's one thing. And then you also want probability of x less than or equal to 5. Probability more than 2 patients. So x greater than 2, or probability that x is less than or equal to 5. Okay. Okay. Is it okay, everybody? Now, these two together, you can put it together by doing the following. Probability of 2 is less than x is less than equal to 5. Probability 2 is less than x, that means x has to be bigger than 2, equivalent statement. Saying that x is greater than 2, isn't it the same as saying 2 is less than x? That's what it is. So we could take these two statements and put them together in one probability notation. So probability of 2 less than x less than or equal to 5. So x falls between 2 and 5, includes the 0.5 or number 5, but does not include number 2. So which is equivalent to saying find the probability of x equal to 3 plus probability of x equal to 4 plus probability of x equal to 5. So this basically is equal to probability of x is equal to 3 plus probability of x is equal to 4 plus probability of x is equal to 5. Now, if you add these numbers, which you already have, you get 68.25%. Okay. Next, again, the same kind of thing. Find the probability that at least, so pay attention to these key phrases, at least 4 patients are cured. Use the results from part B. Do not do the calculations again. At least 4. Remember, I just told you, at least 4 patients. Okay, at least 4. That means probability of x is greater than or equal to 4. At least 4 patients extend their lives. At least 4 patients extend their lives. Okay, so which means what? Probability of x equal to 4 plus x equal to 5. Probability of x equal to 4 and x equal to 5. And these two probabilities added together will yield the final answer, okay, which is 0.33. This is probability of x equal to 4. This is probability of x equal to 5. If you add them up, you get this. There is 33.69% chance that at least 4 people will extend their lives by 20 years or more. I don't know. Here is a thing I kind of want to ask. I went to school back in the late 90s, okay? Mid and late 90s. Back in those days, HIV and AIDS was a scary thing. You know, all college campuses were, you know, we were told about it, we were given knowledge about it and everything. How are things nowadays for you guys? Is HIV, I think it still is a very scary thing, isn't it, HIV?
Yeah, but it's more they're more informed on it. Like they teach us more about like how there's better medicines and stuff for it.
Okay, and back in those days, I think it was more in the 80s. Then, so in the 90s, there was a stigma associated with it. Many people got treated differently, or they were discriminated because of this disease, which should not have happened. However, I think those things have subsidized now. Those things have reduced significantly. Society is more aware as a whole, and people are more accepting. And nowadays, you know, being HIV positive not necessarily is a death sentence. People used to think, oh, okay, somebody's HIV positive, meaning that person is going to die. Nowadays, you know, you guys probably have heard of Magic Johnson, right? You know who Magic Johnson is? You guys, how many people do?
Yeah. Yeah.
Do most of the people know who Magic Johnson is?
Yeah.
Yeah. He was the
Okay.
Olympic runner.
He's the Olympic runner?
No.
What is it? What does he do? What is it? Tell me.
Is a basketball player.
He is a basketball player. Okay. He was like the Steph Curry or LeBron James of his time, okay? He's one of the greatest basketball players ever. And when he came out with his announcement that he was HIV positive back in, I think it was in 93, 94, around then. And people are literally crying, okay? It was such a shock to everybody. People were literally crying. He was such a popular athlete. He was an amazing basketball player. So anyway, so this problem, I kind of find it quite interesting. I made it up completely. Okay, there is nothing called key rates. I just made it up, and this is one of my favorite problems because I take a real world problem and I try to bring awareness to people by solving problems. You get more knowledge, and you guys have more information about HIV and everything nowadays than ever before, I guess. All right, that's all from my side in terms of lecture before the midterm. So any question, anybody? Anyone, anything about any of the materials that I covered? Okay, so for the rest of the class, what I will do, I will just take your questions. So what I'm gonna do, I'm gonna leave it here as well as answer questions on your homework. But to answer questions on your homework, I have to get out of the screen. Everybody has this handout, right? This one, the one I sent you, everyone's got it, right? So if you have any question on the handout, I can go ahead and look it up on my other computer and get to that page. So I'm gonna go to the homework. Is it okay?
Yeah.
I'm gonna go to the homework. So you'll be losing the screen for a second. It should go dark. Okay. Can you guys see my new screen?
Yes.
Oh, what happened? It's not letting me in. Did I make any mistake anywhere here? Okay, so let's see. Email. Oh, okay, I know I made a mistake. Email dash. Okay. All right. Any question about any of this? Let me get to this one. There is a there was something in one of these questions which had an issue. Which one is it? Oh, is this one? Okay, this one. Entering the answer. So make sure that you enter the answer for this one. This is uppercase P, probability of A. Okay, so write it like this. Closing parenthesis. Okay, is equal to probability of A given that B has happened, even if B has happened. Okay, so there's a little bit of issue. You have to kind of play around with it. You see this, let me show you. This extra parenthesis, it kind of doesn't match, it puts it outside. So that's the issue. So let's check the answer. Okay, so just enter it as I did here. It should be good. And once again, the review for the midterm is tomorrow night at 7 p.m. and the midterm is on Wednesday. It will open at 6 a.m. and review for the midterm has been posted online as well. So here it is. Let me show you. There you go, midterm on review. I'd recommend that you go over the midterm review and do all the assignment problems. Then you should be good. Okay, if you can do everything, then you're okay. So for the remainder of the class, I'll just take your questions. So please give me your questions and that will be all for today. I don't want to cover anything new and overwhelm you with materials. So binomial distribution is the last topic for the midterm. And that's it. Everything from day one of the semester up until now, that's all gonna be on the midterm. And to study for the midterm, once again, just do the homework problems and the midterm review. And maybe you could look at some of the examples in the class notes that I have given you. If you get stuck with it, I'd recommend that you collect those questions. So if you are stuck with any of the homework problems or midterm review problems or anything from the class notes or lecture videos, go ahead and collect those questions and be prepared to ask them to me tomorrow night at 7 p.m. All right, so shoot me your questions, everybody.
I have a question. Is the midterm review part of our homework?
Yes, it is.
Okay, thank you.
Any question, anybody? You guys have no questions? Everybody's okay? Or you just haven't done it? Which one?
I have a question for it was on the probability homework.
Uh-huh.
I'm going on the site right now so I can press on the question.
Okay, I'm there right now.
It was. I believe it was question 3. No, wrong question. It was question 5.
Okay. So which part? Everything or just any particular part?
Just everything. I kind of got
Good.
confused with that question.
80% chance of passing statistics and 70% chance of passing biology. And student has 60% chance of passing both. So just create the Venn diagram, that'll be easy.
Okay.
Okay. So 80%, so 60% chance that they pass both. So this is 0.6, right? So think of this as your event space or universal set. 80% chance, so this big circle, you can think of it as 80%. This little circle, or I don't know, left circle is 80%, right circle is 70% or 0.7. So left circle represents statistics, chance of passing statistics. Right circle represents chance of passing biology. And the overlapping portion, the middle, represents chance of passing both, okay?
Okay.
So if you take 2 courses, what could happen? Let's say S is the event that you pass statistics, B is the event that you pass biology. S is this event that you pass statistics, B prime is the event that you fail biology, right? If B is the event that you pass biology, B prime is you fail biology. Or so you could pass statistics, you could pass biology. You could pass statistics, you could fail biology. Okay, then you could
Okay.
fail statistics but pass biology, or you could fail statistics and fail biology. That's all that could happen, right?
Mm-hmm.
If you're passing both, you're in the middle, right? Right here. What are the chances of passing both, which is what? 60%. What is the probability that you will pass statistics only? Statistics only. That will be this region, isn't it? Which is gonna be what? This black shaded region. The black shaded region is gonna be what? If the entire circle is 0.8, you can think of it that way. The middle portion is 0.6. What is the black shaded region? 0.8 minus 0.6, which is what? 0.2. Your chances of passing statistics is 0.2. What are your chances of passing biology only? Biology, let's say this is the red portion. Can you tell me what is it gonna be? So this big circle is, right circle is 0.7. The middle portion is 0.6. So what is the right portion?
Would it be 0.1?
Exactly. So your chances of passing biology only is 0.1. Your chance.
Okay, thank you for
You're welcome. Probably the randomly selected student passes neither of the classes. You don't pass biology, you don't pass statistics. So what are the chances that you pass neither? Look, you could pass both, you could pass one or the other, okay? So this is you could pass both, you could pass statistics, you could pass biology. So it's gonna be what? 0.6 plus 0.2 plus 0.1, which is what? 0.9, correct? So your chances of passing at least one of the classes, at least one means you either pass biology or you pass statistics or you pass both. That's at least one. That means what is left in the sample space? So this is your sample space. That's a collection of all the simple events. So what is the probability that you pass both? You fail both. That means whatever is left outside here, right? Which is 1 minus 0.9, which is 0.1, or 10% chance that you pass, you fail both. There is a 10% chance that you fail both. Is it okay, everybody?
Yeah. Thank you.
Okay. Great. Next question.
Yes, I have a question.
Mm-hmm.
For the permutation and combination, number 8.
Permutation and combination, number 8. Yes.
I'm using the step-by-step example on how to set it up, and I'm getting the same number, but when I put it in, it says that it's wrong.
Are you putting it in this format? That's what the thing is.
Yeah, I'm putting it in the fraction format.
It's still saying wrong.
Yeah,
It doesn't like you.
I don't think so.
I don't know. What answer are you getting? So let's do the problem. It has 5 characters. First 3 are digits. The last 2 are alphabets that are case sensitive. If a thief trying to break this code has a probability of success. So first 3 are digits. So chance of getting it right is 10 times 10 times 10. Not chance of getting right. All the possible combinations are number of ways you can take the first digit 10, number of ways you can take the second digit or pick the second digit is 10, number of ways you can pick the third digit is 10, then the number of ways you can pick the character or alphabet is 52. Are you doing 52 here?
Yeah, 52.
Yeah, you know it is 52 because why is it 52?
26
Tell me.
uppercase and 26 lowercase.
Thank you,
Numbers in
Annalisa.
alphabet.
Yeah, perfect. So if you multiply these numbers out, what do you get? 52 times 52 times 10,000 is 270,400,00. Okay, so let's try to enter it. I'm going to try to enter it. 1 divided by 270,400,00. Okay. Check answer. Oh, it doesn't like me either. Not only you. So this should be the answer. Let me check. Okay, I'll check it. Hold on. Give me 1 second. I wonder if there is a typo here. I'll check it and make sure. This is statistics, right? Statistics, and then it's from permutation and combination, right? Okay. Huh. There are 4 zeros, right? 270,400. It should take the answer, but why is it not taking it? Yes. Yes.
For my answer, I got 2 million instead. I think you should just take out a 0. I got the same exact answer, but you have an extra 0.
I have an extra 0?
Yeah.
Where did I put the extra 0? After 4, aren't there 2 zeros?
After
I mean, there are 4 zeros. Sorry, I meant.
Yeah, there's only 3 zeros.
Is it so? Did it? Oh, yeah, you're right. You're right. Yeah, there should be 3 zeros, not this one. Yeah, yeah. Thank you.
No problem.
Because I multiplied by 10,000. It should be 52 times 52 times 1,000. Okay, so 52 times 52 times 1,000. There's gonna be 270,400. Now hopefully it'll take it. Let's check it. See, now it likes me. Okay, Annalisa?
Yeah, it accepted mine.
So
I
what
was
was
adding 0.
what was the mistake that you made?
I was adding a 0.
Oh, like me?
Yeah.
How did that happen? Both of us making the same
I
mistake.
think it's because I just straight up multiplied 10 times 10 times 10 times 52. I didn't do 52 times 52 times 1,000.
It's the same thing. It doesn't matter because look, it's called commutative property. So what it means is that 2 times 3 is the same as 3 times 2. So it doesn't matter in which order you do. You know what happened? Why I made the mistake? Maybe it's the same reason you made the mistake. There was another problem that we did in the class. There were 4 choices here as opposed to 3. That one had 4 digits, okay?
Mm-hmm.
And 2 alphabets, okay? So that problem was subconsciously in my mind. So you see, I multiplied it by 10,000 because I was thinking there were 4 of them. I still had that subconsciously in my mind. It's actually 3 here, okay? So that's why you multiply it by 3. Okay. Now, is it okay now?
Okay.
Okay, great.
Yeah.
Perfect.
Thank you.
You're welcome. Any other questions, anybody? No questions? Everybody's okay? All right. If no other questions, that should be all for today. Okay. Thank you very much and good luck with the exam on Wednesday. In between, send me your questions. Please don't hesitate, and spend time on the homework, spend time on the midterm review, join the office hours. I'm trying to help you out. But you've got to help yourself. This is difficult time. Times are very difficult for people, for many people now. And I understand and I empathize with you. So I am going out of my way to help you, but you've got to help yourself. So please go ahead and do the homework, try them, and collect all of your questions. When you ask me questions tomorrow, during the special office hours, make sure that you are ready with the questions. You're ready to go. You already have tried the problem or tried the problems, and then you know exactly where you are stuck. That way you will learn, and that way you will get the most, okay? Instead of just saying, oh, I'm showing up, can you do a problem? No, that's not how it should be. You try all the problems and select all the problems, and then you can go ahead and ask me questions. By the way, there is a link here. It says, where is it? It should be somewhere here. This one. You can mark a problem right here. Then go back and find those. Then once you mark it, you can list marked problems only. Okay. So any problem that you're stuck with, mark it. Okay. And then you can collect all the marked problems. So that's something you should do. So when you are asking questions, you know exactly where you are having difficulties with. That way I can right away hit the point. Okay. All right, everybody, that's all for today. Thank you so very much. Good luck once again, and wish you the best. We'll talk to you on tomorrow at 7 p.m.